All right, guys, Mr. Antonucci here, and in this video, part two, we're going to talk about how to calculate the standardized test statistic and p-value for a test about a difference between two population means. So when the conditions are met, the three conditions, the random 10% and normal large sample, then we can use the t-distribution with degrees of freedom calculated by the technology to figure out the p-value. So if the conditions are met and the null is the mean difference is equal to zero, then this is how you calculate the standardized test statistic. You do the difference in sample means minus zero divided by the standard error. And the p-value, that is going to be arrived at from either the t-table or technology. We're typically going to use the calculator for that. And that's the probability of getting a t-statistic that large or larger in the direction specified by the alternative hypothesis. Okay, now a note about this specific formula is not on the AP formula sheet for the AP exam. However, the general formula for how to get the standardized test statistic is it's always the same form, statistic minus parameter divided by the standard error of the statistic. And the formula for the standard error of the difference in sample means is also on there. You just have to know how to combine those in order to get the standardized test statistic for a difference between two population means. Okay, so let's take a peek at an example. And in this case, we're going to look at the calculator to show you how to do this on the TI-83 or TI-84. So we can use the TI-83-84 calculator to perform the calculations for a significance test of the mean difference being zero. We're going to look at the data from a previous example that we did in another video that dealt with the monthly rent of one-bedroom apartments in New York City and Chicago. So I'm going to show you how to do this all on the calculator. So first thing you want to do, turn it on, clear anything off, and then hit the stat menu and go over to tests. And since we're talking about a two sample t-test, that's the one we're going to scroll down to. That's number 4, two sample t-test, because we're doing two samples, okay? In this case, you can either put in the raw data if you have the individual values, which we originally did, but then we calculated the summary statistics for those rentals. So we have the mean and standard deviation and sample size for sample one. You would enter that raw data in there, or excuse me, not raw data, that's those summary statistics. Enter in each of those. Make sure you pick the correct alternative. In this case, we're looking for a greater than alternative hypothesis. And you always leave it on no for the pooled, and then we're going to calculate that. And so what this is going to do, it's going to give us our t value, it's going to give us our p value and the degrees of freedom, as well as reproduce the summary statistics for us. But it's important to note that the t value and the p value there is how we get that on the calculator. Okay, so let's look at a specific example where we're going to run through all of this stuff. If we think back to that tree example that we did in the previous video, this table has the summary data, and we want to calculate the standardized test statistic here. So here's how we do it. We use this formula. Remember, we had this formula right here. The difference in sample means minus the hypothesized difference, which is zero, divided by the standard error. Okay, so you could just plug this information into the calculator and get it to produce the t-value, or you can do it by hand like this. And with that, our test statistic is going to be negative 2.628. Okay. And then we want to find the p-value using technology. The p-value that corresponds to negative 2.628 with 55.73 degrees of freedom. Now, again, that degrees of freedom is calculated with the calculator. It will calculate that from technology. So the p-value is 0.011 there. So with that, we can actually make our conclusion. So because the p-value of 0.011 is less than our significance level of 0.05, we reject the null. What this means is that the data do give us convincing evidence of a difference in the mean DBH of all trees in the northern and southern halves of the forest. So what does this p-value tell us? Okay, it's important to notice. That means if there is no difference in the mean or in the mean DBH of trees in the northern and southern halves of the Wade Tract Preserve, there is a 0.011 or 1.1% probability of getting a difference in sample means as large or larger than what we got. And remember, that's negative 10.83 in either direction. So less than or greater than 10.83 or greater than 10.83 or less than negative 10.83, purely by chance and random sampling. So with such a small probability of getting that result just like that by chance alone, if the null hypothesis were true, we have convincing evidence to reject the null. Now, one thing is we can get additional information about the difference between the population means in this example with a confidence interval. Now, using technology, the 95% confidence interval would be from negative 19.09 to negative 2.573. What's nice about the confidence interval is it gives us a range of plausible values for the actual mean difference of all trees um, in the southern half. All right. Well, guys, again, hope that was helpful to you. Reach out if you have any questions. Take care.